Okay, just to recap what we discussed in the previous session, was the first session yesterday. We started with the basic introduction to core data services. We understood the core data services architectures from the ABAP on HANA perspective, and what we're going to cover in terms of modeling us analytics scenario by leaving the transaction development scenario and UI development scenarios. This is for the core ABAP on HANA's or ABAP as for HANA ABAP technical skill set. Okay, and we looked at the basic introduction to ABAP development tools in Studio, HANA Studio, or Eclipse. You can use one of them. And then we started with creating a simple report program inside the using the ABAP development tools in HANA Studio. So it was all good, and then let's get started with creating core data services objects in the system. Okay, we have got enough introduction, and we're going to learn, and we're going to come back to the topics again and again to understand, is it making sense to understand the serious concept in general. So it's going to be a repository object. What I'm going to create, it's a serious, it's a repository object which can only be created in ABAP application development tools, cannot be created inside the GUI screen of the classic SAP GUI screen. And then when I create a serious view, I'm going to create a DDL source, which is a data dictionary language source file. And then the source file is going to create two objects. One is going to be serious entity, and the other one is going to be SQL view. These are the two objects it is going to generate. And wherever I'm going to represent my serious view in ABAP programming, I'm going to reuse the serious view entity as the object to represent this object. And wherever I wanted to understand this in the database, in HANA database, I'm going to represent SQL view, which is going to be another entity generated as an activation of the DDL source. So DDL source is a place where SAP is allowing you to create a dictionary object or database object, because we don't have a screen like SE11. So SE11 is going to do the same thing for you to do whatever the DDL source is doing, as SE11 was doing in the past. So since we don't have SE11 data dictionary, which is a form-based interface where you can define the structure, table types and table field data elements and etc. to define a table or view, and then automatically dictionary objects will create it in the database. So there was a process. So there is no such process inside Eclipse or HANA Studio. So we are going to achieve that process through the DDL source object, which is a serious based DDL source object. And then internally it is going to generate two objects. One is the serious view entity and as well as SQL. We're going to see all these three objects in the system and how they represent and how they're going to be used in further. Okay. Okay, let's get started in the system. I'm going to create a very basic, simple serious view, and we're going to go into the more complexity of increased every day. We'll go to the favorite packages. I've done this one yesterday, and I'm going to choose my package. I've created a simple source code report program yesterday, and this time I'm going to create a new core data service object. For that, I can create a sub package for that, or I can just go and do all my serious views inside the main package. It's up to how you're going to categorize your packages in a hierarchy. Okay, just that. What is that? I'm going to say new about package. I'm going to put this as basic, and I'm going to represent only basic serious views in there. The basic CDS views are your interface CDS views, and they always going to be created on database tables, direct database tables. Okay, so in basic CDS is part of your interface CDS. Interface CDS views is going to contain two layers. One is basic, which will hit the database table, and then composite is going to be using the basic CDS views to be able to join to other database tables as well as other basic CDS views. I'm going to say just this is organizing my packages in a simple way. I'm going to put this package also into the same transport request what I created yesterday. I created my package which is um, done, and I'm going to choose this package and say start creating my DDL object new. This time it is going to be an ABAP repository object. I can search for it. I can search for code data services, and you get a folder. You got different source files in there. The one I'm going to choose is for CDS view, the basic CDS view creation. I'm going to say data definition, and then say next. And I'm going to give the name for the CDS view. I can give any name, but I wanted to give the name what I wanted to use it for CDS entity as well. So it's a very it's not mandatory, but a very uh, best practice to use the source DDL source data definition object as well as your CDS view name same. So what I'm going to do, I'm going to give the name as basic CDS. That's going to be my CDS source name. I can say source DDL, and then I'm going to say next. I'm going to put it in the same request. Then I got several templates to choose so that it gives me some um, ready-made template to go to replace my values. I don't want to use the template first. I'm going to keep it very blank and say finish. So it's going to get into the blank screen in there, and I can write my code uh, for for building the CDS view in there. So generally, you need some annotations at the view level. There's going to be view level annotations, and there's going to be some annotations at the field level we will need to define that particular field. So the mandatory annotation which is definitely required is the SQL view name. So if you don't remember or if you don't know what annotation you're going to use, just press at the rate, and then it is going to prompt you several annotations starting with alphabetical order. So I'm going to choose ABAP catalog SQL view annotation. So that is one of the mandatory annotation. I'm just giving a SQL, as I said before, when the DDL source is going to get creating two objects. One is CDS entity, which is CDS view itself, and there is a SQL view, which is a data dictionary object or database object. So I need to give a name for the data dictionary object as well. So I'm going to say ABAP catalog, and then SQL view name. You can do the code completion by specify control space. It's going to show you what are the available annotations with that possible description. So I'm going to type in, or I can choose one of them. My annotation or I required is a SQL view name. So as I selected this one, it is going to put me in this way. Between the quote, I'm going to keep my SQL view name. SQL view name cannot be the one what I use for my source file name. I have to use a different name for the SQL view name. So I can say JI and then say basic CDS. Should be okay. And the other annotation which is also maybe useful is end user text. You can say end user text dot label, and then give the name as basic CDS view. And that's it. And you can have more annotations to define a CDS view, which are really not required at this moment. We're going to create a very simple CDS view to start with. I'm going to start with a define view statement, which is something like similar to create view in your native HANA or native SQL. So saying define view and give the data the CDS view name. This time it is a entity, the CDS view name itself. So I wanted to always, as I said, I wanted to keep the same name as my CDS source file name. So in this case, it is basic underscore CDS underscore test. That's going to be my name of the CDS view. And then as what? As select. It's the same SQL view creation in your native HANA database. Select um, from, basically you're going to select from certain table, right? That's going to be your data source, and then you may select all the columns from the database table or certain columns from the database table to create this view. So I can take some of the columns from the table, or I'll show you. I think I can take all the columns from the table. It's okay. So select from the table. This time I'm going to take it from T001. That's the basic standard table what I'm going to use for this example. I have all my code representations here, so I can, if I wanted to get the easy access to my code, I can always get it from these snippets. These are all available for you to download and use it for your purpose. I also give some text to each annotation and what is it is used for and why we are doing this way. So I'm going to say T001 as the table. That's a company code table. And then that's you define the data source from where you're getting the data from, and then you're going to define uh, what are the columns you're going to use between the brackets. So let's say if I don't know what are the columns I wanted to take them, you can just say control space, and it's going to list all the columns from the database from this T01 table. So I can say insert all elements. It's going to put everything from the table, which is a big list, or and then you can choose any column what you don't need it. For example, I just need PUKRS and land one, and then currency. That's it. I just wanted to remove all the other columns. I can do that as well. And then that's it. I cannot have comma for the last column, so I can just say end it. So that's a pretty basic view definition. I'm defining this view from the table is going to be my data source, and what are the columns I'm taking. There are 4 columns I've taken from this particular table to define this view, and that's it. What all I wanted, and then say activate it. Okay, it's activated, and you can see in the bottom left corner the outline window. This is the view. Defined a basic series underscore test, and it is selecting from the data source, which is T001, and the elements are is ones and the key is BUKRS. So this is what it is defined as the CDS view. And then I can define, and if I have to represent the names of the objects, this is going to be my data source. This is going to be my CDS view name or CDS view entity name. And this is my SQL view name, which you can see in SE11 data dictionary. And this is my DDL source name, which is allowing me to create a database entity without having SE11 data dictionary window. So this is what I have it in my diagram before. So you can see that this is the structural hierarchy. You're defining the data source, DDL source, and then DDL source is defining a SQL view and as well as CDS view. So wherever you're going to represent this particular CDS view, you're going to represent this one as an above. You don't represent the one which is created in the data dictionary. You will find this one in the data dictionary of above system, which is LC11 is going to contain this one to represent this view, and this wouldn't be there. The CDS view wouldn't be there. But in order to use it in programs, above program or OpenSQL or any other CDS view, or for any reporting application, you're going to use this one, not the SQL view. Okay. Okay, that's about the simple CDS view creation. And then what I'm going to do, I'm going to create another one this time with some additional annotations. Okay. Any questions here? Whatever the documentation you need, I already documented in this Word document. You're going to get the PDF version of this document as a downloadable document so that you can use them to follow through my notes. Also, you have these ones which explain each topic. So if you can see in this place, this is what we started with VDM in detail. And we are starting with the exercises. This is some of the general theory, programming model evaluation, and also VDM in general. And this is a concept which I didn't discuss at this time, but we'll cover this after. This serious ones concept, two flavors, is basically talking about native HANA CDS view and above HANA CDS view. What is difference between them, and etc. It's going to talk about this one. We can cover this topic sometime later when we understand above CDS views a little bit more, and then we can come back to this topic. And then this is the place where you're starting with finance model. This is T01 and ACDOC, currency dimension, CDS views. This is all part of your finance CDS view model I'm creating. I'm not using any standard CDS, which is SAP given standard CDS view models. We'll come to that in a later point in time when we understand the custom CDS view creation from the scratch, from the very basics. And if you look at the standard CDS view, it's going to give you a lot of uh, um, confusion because it's so big. It may have 200 lines or 150 lines, and you may get over. This is so complex. But if you spend 10, 15 sessions, and then you go back and look at the standard CDS view, which has 15 associations and a lot of semantic and 100 lines of code, which will be definitely look very easy for you. You will be able to understand easily. Okay. So this is about IDT configuration, and you start with the basic CDS view. This is what I've done. From the notepad snippets, there is a navigation you can go. These are the notepad snippets I'm using. So the first example I've used from the finance model. This is what I've created. And then you can also create another CDS view for currency, which is going to be from T table, these tables, and then I really didn't do anything great here, just the same syntax of having SQL view name. This is a mandatory annotation. Without having this annotation, you cannot define a CDS view, and the rest of all the annotations are optional, and also depending on your requirement, you can define those annotations. I'm not defining this annotation right, this particular CDS view. This is very similar. Okay, I think I wanted to define this CDS view as well. The reason for it is I may wanted to go with another example, which is going to join these two CDS view. So for that, it will be useful, but I'll come back to those CDS view joins in a later point in time. So I'm going to jump to another example, which is having a join between two tables in your ABAP system. Okay, let's copy this. I'm going to use this code, but anyway, we're going to write this code again in the system instead of, because we are starting initially, so we don't want to just do the copy paste, so you miss a lot of things. For 1 or 2 sessions, we'll do we'll do the coding directly on the system, understanding code completion and also representation, and then we'll copy it. If it is coming again and again, same thing, we can go to copy paste it. Okay. Now I'm going to go to the next example. Actually, before going to the next example, if I wanted to show, if you wanted to display the data, just go select and then say open with your data preview. You're going to get the data preview in there. You can apply, you can see this, the filters here, add filters on any of the columns. You can also go to the SQL console and then modify the SQL which is generated for this particular series view. These are the 4 columns and from, and you can apply where clause and group by aggregations also to see what it is about, and then you can just run it. And then and also you have a SQL which is generated for this particular view definition. Say go to the context menu and show in not the show in open with SQL. Sorry, not this one. Show SQL create statement. It's going to show you the native database SQL which is created for this particular series view. So if you remember or recollect refresh your knowledge with your database, so create view name as select from all these columns from this table is the core native database syntax, right? That's what it is getting generated in the background for your database for your CDS view creation. Okay, so it looks very similar to SQL. It's an extension to SQL, but finally, in the end of the stage, it's going to create a SQL for you. That's how database will understand the object existence, object creation, and object execution. Okay, that's all for this initial example. I'm going to go to the next one, and this time I don't want to go to the package and then choose the core data service because I already have a folder or the grouping for core data services because there is one object already created. Now I'm going to go to the core data service folder and choose another data definition. So this time since I'm getting something um, from the existing notepad files, so I'm just making sure I wanted to give this CDS view name as something which is similar to what I'm going to use. So what I'm going to say this time, ZI and then company code with join. This is the CDS view detail source I'm defining. I'm going to name this as company code join. I'll say next, then say next. I'm going to put the same. I can still, I wanted to use this define with join. I can do that, but that's fine. I'm not going to still do that, define this template. I'll write it my own so that I can understand in more better way. So I'm going to copy paste this one for just for reference purpose. In order to uh, not to switch between two interfaces. So the first annotation, as I said, ABAP catalog, you know that this is going to come in the code completion, and you're going to choose or you're going to type in ABAP catalog, and then dot SQL view name. That's going to be coming in there, and then choose enter. It's going to propose you. So the SQL view name is coming here, and then you say the name. I wanted to give add ICMP. You cannot have the view name which is created in the past. So I'm going to say something like this, and then authorization check. I don't really need to have authorization check right now because we didn't go. This is going to be the last topic we will discuss in order to understand the authorizations. Okay, and then the other annotation which we already talked about is end user text, which we already seen. So I can just copy paste it. So now I'm going to say define view, and then going to give the name, which is the one which I just gave for DDL source, that is CMP COED, and join, and then say the view name, that's the view name, and then from sorry, as select from where. So I'm going to use my left primary data source as T001, that's my table. Okay, and then I'm going to join this with um, another table which is T005, that's for currency. Okay, and on what? This is a very pretty much same or easy or the same, what do you call, native HANA or native SQL, which you generally see everywhere. So you're saying left outer join to T005 to 5T table, and what are the columns you're going to use it? I'm going to use a join condition based on land1, which is common in both tables, and also mandate, and also I wanted to apply a filter on language to E. So I'll just copy paste. This is a very simple join if you are familiar with native HANA SQL. So I'm saying T001 is my source, the primary data source, and this is my target. So I'm saying land1 of T001 table is equal to T005T land1, and also I wanted just little format so that I can understand it. I also applied filter on language so that I don't want to show you any other language data. That's it, and go to home. And then what else I made a join, and I'm going to define the columns. So if you just say open brackets and brackets with these, and now you have the option to say control space and insert all elements. So insert all elements is going to define all the columns from your left and also all the columns from the right. So just do this one, insert all elements. So now you see all these columns, the initial columns are from the initial table, which is T001, and then you can also see the T005T columns as well. I also see that the template gave you wherever the column name is same, it is automatically associating the table name to make a differentiation. This is a SQL concept. It applies to CDS as well. So if you have a common same name column in the join operation, you'll have to define with the table name associated together. So I don't really want all these columns. I can just say Control Z, and then can define my key columns, which are I'm going to say from T001, I will say the BUKRS, and also give the comma separation, and then say T001, and then Control K is giving me all the columns. I can take text, and then a couple of columns from other table, which is T005T, and then say land X, which is the country text. It should be okay. That's it. I just took one column from the right hand side table, and I can have this filter T00 language E here, or since I already have it, I just wanted to keep it not in the join, but in the where class so that it can be acting as a filter to it instead of join. But join itself can do the same as implicit filter. So I can remove this whole thing. Okay, that's it. I've created a simple CDS view with a join condition. I'm activating it. It is activated, and then as soon as it is activated, you can get the land description, the country description from the right side table in order to show in this example. Okay, I'll say open with data preview. You can see this country's text, the description is coming up for each company code. This is how a simple join is being made. Similarly, now we're going to extend our new logics with more annotations and more expressions, functions, and etc. with the next example. So I'm going to start using several copy paste as in when needed. If we didn't do a such annotation, we're going to understand by writing it. And if it is already described and discussed in the past, we will copy paste that. Okay. Any questions? And then we'll go on more. So you can try with other joins as well. You can try inner join, right outer join, cross joins, basic SQL joins concepts. You will be able to apply in this video creation. There's no difference in native HANA SQL versus CDS View SQL in terms of joins. Okay. Now I'm going to switch to the other topic, which is going to be expressions. So we just used the joins. You you have the option to do several other exercises for inner join, right outer, full outer. These are the different types of joins between two tables you can use, and you try that out with your simple. There are some exercises for those ones. You can follow through that. Okay, so now we also wanted to talk about alias name. If you remember when we were describing the CDS view here, the one we just created, all the time we were actually giving the table name. So if the table is really big, like Z custom company code or something, we don't want to give the complete name of the table all the time. And so for that, you can use alias for those tables. So something like instead of having T001, you can say T. So wherever you wanted to use T001, you're going to use the T there. This is what alias meaning. So same native HANA or native SQL concepts apply here in using the alias for that. So do I really have to use that alias? It's really not so complex. You can say use the alias for T001 table as one T1, and then T005T can have T2. So represent T1 and T2 in the join condition as well as when you are accessing the column names in there, in there, in the field definitions. Okay, that's about alias. And we also looked at the where class. If I just wanted to keep this filter, which is in the join condition, out and put it in there in the where class, it's going to be behaving like a filter, where class filter to filter out the data to only to this particular um, language. Okay, I'll say where, and then I don't need to, I can actually skip this one here, and then we'll remove and there. And this is going to be working as a where class here because it's not in the join, but it's a filter. So you can see the SQL which is generated for this one. Show SQL. So you see that the where class for the language is applicable, applied to E. Okay, so that's how it's defined. So you can just check the data. It's going to display only the language English. Okay, this is it. And then the next syntax what we're going to look at is expressions. Okay, expressions like arithmetic expressions or case expression, if class, all kinds of different expressions you will be able to use inside the CDS view. Whatever you know inside SQL, in terms of expressions usage, you can do them in you can do them in CDS views definitions as well. For example, I'm going to take a look at the snapshots from there. So this is my expressions scenario. I'm going to take this one for my reference, but yeah, if there is anything new, we're going to use that. If there is any errors, also we're going to look at that. I'm going to say data definition, new data definition, and I'll say this time it is for what? This is for the finance model I'm using, and this is for the ACDOC expressions example. So I'm going to say ZI ACDOC A and expressions. I'm using ACDOC A table for expressions. Okay. I mean, I can use any table, but just this is going to be the finance model object. I can use this one for. I'll be this time I wanted to use the template, which is okay for me. So I'm going to use the basic define view template. I am not going into the joins or any of the associations or parameters. We're starting with basic define view template. Say finish. So as soon as you choose the template, it is giving you some uh, template code there. I'm going to use that and replace some of them to to complete my example. Saying above catalog annotation SQL view, this is what it is giving by template. I'm going to say replace it with whatever I wanted to give the SQL view name. I'm saying doc A or ac expression, something like that. And then compare filter. We don't need to do this compare filter right now. This is going to come during associations. And preserve key also not required. Either you can delete, not required at this moment, but it is going to be required at the associations or the foreign key association. I'm going to say either comment it by having two, or actually you can comment by forward slashes, two forward slashes as well. Whatever the way you can comment it, its compiler is going to ignore it, or you can completely remove it. And then access control, as I said, we will talk about says code, access related things in the last part of the CDS view. And then finally we end up with end user text label. That's going to be what it is proposed by system. So this time I'm using template given by SAP for creating a basic CDS view. And then it is defining a view, and then you can see that system template automatically taken the view name as the one which is DDL source is created, and it is select from data source name. The template is asking us to give the data source name. This time it's going to be my table ACDOC. And then what are the columns I'm going to need? I will have to put inside this brackets. Okay, I can just define the column names, or I can actually make some expressions added to it. For example, I can add case expression, I can add if expression, or I can actually multiply or plus, minus. There are a lot of automatic and case and logical Boolean expressions, null value checks. You can do a lot of, I wouldn't say every native HANA expression is allowed inside CDS, but most of them are allowed. Most of them meaning in order to get the performance pushed down to native HANA, they're allowing almost every expression in CDS view as well. For this example, I have taken some of the simple uh, expressions to show you, but we'll go into some more later. So what I'm doing, I'm going to copy these columns, So I just took 5 columns, right? Or 6 columns, and as they are. So I'm not doing any transformation to those columns. They're going to come just like as they are. Okay. And then for the some more columns, I'm doing some calculations. When I'm defining this view, instead of just reading the columns directly from the table, I can apply some expressions or some filters or some calculations to it. So that's what I'm doing. I'm applying a case statement um, on a column called AWTYP, and then I'm just checking the condition when the BSEC is the value, then take the value as finance document, and then and this is the other value, then take this one, and then yeah, this is a simple case statement based on the values what I have in that particular column. And then the next transformation, I'm just keeping a fixed value, a literal value. So you can say, okay, I wanted to keep the application column always constant. So I can say S4 HANA, that's going to be my fixed column value. It's going to be same for all the records. And then finally, I'm going to say a balance column. And then I wanted to apply some calculation to the balance column as well. So this is how I made some transformation, simple transformation while doing the define view. These are not something great thing what I'm doing, because if you remember how you create a SQL DDL view inside native HANA system, you create this one. Do you create view, create database view, and then create the columns, and you also apply some case statements and if else statements, or any kind of simple transformations while defining the view. This is what I've done. I've done nothing different there. So what I'm going to do, I will remove uh, the snippet, and it is complaining with an error saying ACDoc here doesn't exist or not active. Um, that's it. This is the table name, and then it's asking to define a key. Client field doesn't need to be specified in client specific um, uh, view. So if it is a client specific view, by default, it is going to be client specific view. I don't need to define a client field. You know, client dependent and client independent. It's been in native HANA we have seen already. So if you have multiple clients like 800, 300 systems in your ERP or S4 HANA system, and you want it to be client dependent data, and you're going to choose client dependent. By default, it's client dependent. And we don't have to explicitly say client dependent for that. It is always going to be. And there are multiple clients. You choose cross client in the native HANA system. And here you choose client independent, which is going to give you all the clients. Okay, so now I made my CDS view, and then I can actually go to data display and data preview. You can see this application has been always constant, and then document source is most of the time it is other document, because that's how the type of the column is being taken. Some of the columns, of course, material documents as well, because of the MK. This is a case expression statement, and you can also see the balance is being recorded as 530 and is multiplied with 2 is for balance updated. So this is a simple manipulation or transformation I've done during the view generation. So these are very important. It looks very simple, but over a period of time, you're going to, while doing the complex CDS views definition, you will be doing a lot of transformations to the existing columns and define a new column to it, or modify the new column logic and replace it with new columns with the logics of what you're implementing here. Okay, and then um, I'm going to go into the other examples also for to look at some more expressions. They are taken from other models, which are S-flight, for example. Um, yeah, so you can see this is a constant. You can say you can also apply concatenation to two columns, and you can also apply. Oh, actually, this is function. Just sorry, I haven't gone to the. It's mixed up here. So sorry, you just don't. From this example, you can only understand the case statement and also the constant. Both are expressions which you can try and practice from the S4 S-flight model. I also have complex case expression. So in this model, you got complex case. For example, while you're defining this particular series, you're saying when class is F, then this is one, and then you have when um, there is another column is KZ and another column is greater than the previous case. It was just one column. We were checking the different values. Case when this column name is equal to then we are the same column with for different values. We are defining different results. But in this example, for the different columns, here this in the when class, this is for class column, and this is for the unit column, and this is for the else part is for the blank. So this is a complex case. You also have complex other case for other logic, nested case expression in this example. You wanted to try this once, try it out. But yeah, this is a simple, it's not a simple, this is a complex case expressions you wanted to achieve some transformation you wanted to do while you are defining the view from base tables. You are transforming some um, some of the columns with some additional logics in there. Okay, I hope you're going to do these ones with complex case expression 4P and 4C and 4D for understanding the expressions. And the next topic I wanted to talk about is functions. Okay, built-in functions. We're not really talking about custom functions here, which is completely different logic in place for the table type function creation. We'll have to cover as part of BAP managed database procedures, which will come in the very end. The functions here, I'm talking about the basic standard built-in functions. For example, I wanted to do concatenate. There is a standard SAP function given to you to use it and do the concatenation. Similarly, you wanted to get the difference between two dates, or you wanted to know the today's date, and at the same time you wanted to apply some string functions like trimming left and right string values. Uh, any kind of function what you see in inside the serious language, you will be able to use it and make use of it. So they are very useful. Having functions while creating your model is going to be very useful for you to do. You may, for example, you wanted to get the difference between today's date and the last day of the last month. So you don't want to calculate and write a program. There is a function. If there is a function already given by SAP, use the function and pass the parameters to that function, and you're going to get the result out of it. So those are the ones which are called standard function. So you wanted to see all the list of standard function in my serious view model nodes. I've given ABAP keyword documentation. You can just go to the documentation, and then you're going to see um, functions in there. Anyway, we're going to use, this is very simple thing for you about dictionary, and then about reference, sorry, about serious in about dictionary, Serious annotations, data definitions is what we are looking at, above serious views, and above serious detail for data definitions, and then above define view, and and inside the above serious select, we are at data source, and then associations is something else, but we are at built-in functions. So you got SQL functions and special function. You can take a look at the SQL functions, numeric functions. So absolute, seal, division. These are all the different functions you can apply on columns or values to get some value out of it. Okay. This is a standard doc. This is a simple syntax which you also can use. I've used these examples in my exercises. We'll take a look at it right now. And then there are string functions, concatenation, left, right, length of the string, padding, and replace something with other argument. All these functions, they're going to come very handy when you are doing a lot of new field calculations inside your serious view model definitions. Okay, this is another example for that. You can just take this code and then run in the system. You're going to get that. And there is a special functions, for example, conversion functions. If you remember, type conversions from data type from 1 to floating to decimal, binary, sorry, the int to begin, something. These are the conversion functions which you can use to convert the data type to another one. And finally, I think there was the date functions. As I said, date functions are very useful in calculating the days between, months between, and this is pretty uh, similar to what you have done in the native HANA database if you are trying to recollect. So you wanted to write the SQL procedure code or the SQL function. I'm going to use these functions a lot, every time, most of the time, or even for your modeling scenarios where you're defining calculation views. And you go to the modeler editor, you got the option to choose the functions from the modeler window. So those are the standard functions available there. Similarly, serious view has got a lot of functions to be used. Okay, so you're going to use those functions a lot. So the timestamp function, time zone functions, and date conversions. It's a lot of documentation. So if even though you don't remember that particular time of instance, you come to this place and then get the syntax of it and then use it in your system. So I'm going to grab one example and then show you how I'm going to use the functions there. Um, every document what I've shown you is listed in there, so you can follow through there. Okay, I'll copy this one and then show you how I am going to use. Okay, we go into the data definition and then just go to new data definition and then say I. We're saying functions, built-in function. Built-in functions, part 1. I can say 1 because I will have another example to show you date. I'll say next, and then I don't have to choose any template because we know what the template is going to give you. So I'm going to just copy paste. This is not a new any annotation I'm going to say. Just one annotation we're going to see in this example, which is going to be client handling type inherited. So as I said before, I was talking about this one, client dependent and client independent. This is what, if you have multiple clients, dependent is it's going to get to the login client what you used. And if you don't do make the There is previously we used to have client dependent annotation, so that's been replaced with this client handling type, and we don't have to use the previous one, which is you know previously used for client dependency check. So inherited meaning it is going to take the system client, whatever the client you logged in, it is going to take that inherited, take it from there. So it is complaining because I have already used this function, the name. I'm going to say uh, I think just the built-in. Sorry, I come on, build functions one, and then I can say act. Okay, same thing. Okay, that's it. So here I have some concatenation to these two columns and absolute value of total balance and length of account number, and document text is only taken from the last left of four. So it's just going to get the left of the four letters of the total text. So you can just do this one. This is done. So I can display the data out of it. So you can see the balance has been absolute value now, and it is compounded with document type, and length of the account number is always 10, and then this is how the document text is being taken as first four letters, actually left four letters. Um, that's about the function, and you can also take a look at the date function to understand how the date calculations can happen. I've given you another example just below to this one, and then you should be able to, this is going to get you the date between BLDATA versus posting date, and this is going to get you 3 days more or next to what the posting date is, and this is going back 2 months because it's add months to the date what it is in the posting date. So you can actually understand these three columns with these date functions by using this example for date function. Okay, this is going to be end of topic two, the day two session, and we're going to cover aggregations and other topics in the next session. So I'm going to stop here, and then if there are any questions, you can let me know.